Okay, this is part 2 of lesson 5.1, and the reason I split this into 2 videos was because example 1 is something you can probably do now with your prior knowledge and with what I showed you about secondary trig ratios, and it might be worth it to give it a shot if you're confident in your solving for angles and sides using the primary trig ratios. So if that's the case, pause the video and give this question a shot. But before you do pause the video, there are 2 typos that I've now turned this into the 3rd take of this video because I haven't discovered them until I started doing the question, and it really messed up the diagram. So the first one is that the first side is AC, not AB, and the angle should just be angle C, not angle CB. We don't name angles with 2 letters, just one. So now that we have the question corrected, you can give it a shot. And what you're going to do is solve the triangle, which means find all sides and angles. And you're going to determine the primary and secondary trig ratios from angle A, much like I did in the first part of this lesson. So if you want to, pause the video, give it a shot. If not, stick it out with me and we'll solve it together. Part A says solve the triangle. So I'm going to start by drawing a right angle triangle. I'm not going to label it. There we go. I will draw the 90 on there though. And now I'm going to consider what I've been given and start labeling the triangle. We were given that angle C is 90. So that means that the 90 has to be C. We weren't given any of the other angles, so we can pick which one of these is A and B. I'm just going to say the top one's A and the bottom one's B. And now that we've got triangle ABC, we can label the sides. AC is 3 centimeters. BC is 4 centimeters. We don't know AB. All right, let's get started. We want to find angle A, angle B, and side C. Well, since we have 2 sides, we can use Pythagorean theorem to find side C. So let's start with that. A squared plus B squared equals C squared. Fill in what we know. A is 4, B is 3, and we don't know C. A is 4 because A is the one across from angle A. B is 3 because B is across from angle B. 4 squared is 16, 3 squared is 9, we still got C squared. Add 16 and 9, we get 25. So C squared is 25. If we want to find C, we square root both sides, and we get C is 5. Now we know angle C, or side C, 5 centimeters. And I add that to my diagram because now that's a piece of information that we can use to solve for other pieces of information, like angle A and angle B. Let's try to find angle A. Let's start with A. We were given 4 and 3 as our sides, and we just found 5, side C. So now we can use any of these sides. I'm going to use the 2 I was given in the question. So from angle A, I'm going to label my triangle. We've got O, A, and H. That's from angle A. So from our reference, I'm going to do 2 there. O is 4, A is 3. Those are the 2 we're given. If I write out SOHCAHTOA, the 2 sides we know are the O and the A. We know H2, so I could use any of these, but the ones we were given at the beginning were O and A. I'm going to pretend I haven't found C yet. I'm going to use TOA for O and A. So tan A would be O over H. O over A, sorry. Opposite over adjacent. Tan of angle A is opposite over adjacent. Let's fill in the ones we know. O is 4, A is 3, and we're set up to solve for tan A. If I want to find A, I use tan inverse of 4 over 3. And take my calculator here. Make sure my calculator is in degree mode, so I'm looking for the D or the DEG, and I'm going to do second tan 4 over 3. Oops. And I get 53.13. Doesn't tell us what to round to. The only angle we're given is 90, no decimals, whole angles. I'm going to go with whole angles. Round to what I'm given in the question, 53 degrees approximately. So now we know A, I'm going to put that on my triangle, 53 degrees. And if I want to find B, we could use a trig ratio, but we could also make it quite simple. We know two angles in a triangle. All of them should add up to 180. So if we subtract the two we know, we'll get the angle we're left with. 180 minus 90 is 90, so really these two will have to add to 90. And if we subtract 53, we get 37 degrees. B is 37 degrees. If I add that to my triangle, the triangle is now solved. We know all the angles and all the sides. The new piece is the secondary trig ratio stuff. So from angle A, I've got my triangle labeled. We've got 3, 4, and 5 are our side lengths. So for B, if I'm asking you for the primary and secondary trig ratios from A, I'm asking you for what sine A is, what cos A is, what tan A is, and what ratio it is. So keep it as a fraction. Now we already did tan A in the question to solve for angle A. It was 4 over 3. Sine A, so from A, sine is opposite over hypotenuse, so it would be 4 over 5. And cos A would be adjacent over hypotenuse, or 3 over 5. Now the secondary trig ratios, this is the new stuff. This is what we got to remember. And the way I like to remember it is, if you can remember that the three ratios are cosecant, secant, and cotan. Cotan goes with tan. So cotan A goes with tan. Tan and cotan. It kind of makes sense that they go together. It's the reciprocal of tan. So that means its ratio would be 3 over 4. And then to remember which one goes with sine and which one goes with cos, you alternate s's and c's. So sine is an s. It needs to go with a c. C is cosine. Or not cosine. Wow. Cosecant. That's the other one with a c. The cos would go with secant. The other one with an s. There's an s and a c pair. That's the only way I've ever tried to remember it. You might come up with your own way that's better, and if you do, tell me. Maybe I'll remember it your way. And cosecant and secant are the reciprocals of sine and cosine, respectively. So cosecant would be 5 over 4, and secant would be 5 over 3. And that's exactly what part B is asking. It's not asking you to evaluate, because if you now evaluated for A, you get the same 53 degrees regardless of which ratio you used. We just want the ratio. Ratio means fraction. We just want the fraction. All right, that's it for example 1. Example 2. Solve for the angle. I'm going to change this last one to cotan. And I'm also going to change these instructions. Boy, a couple mistakes here. Determine the angle to the nearest tenth of a degree. We're not going to determine the other 5 ratios. That's excessive. There will be questions in your homework and warm-up like that, though, and we'll do them in class. Determine the angle. So what happens if you're asked to solve for the angle and you're not given one of the primary trig ratios? There is no cosecant inverse button on your calculator. So what you do to solve is you remember what ratio cosecant is related to. Cosecant is the reciprocal of sine, 1 over sine. So if we want to know what sine is, we take the reciprocal of 2. 2's reciprocal is 1 over 2. And now, instead of solving cosecant theta equals 2, we can solve sine theta equals 1 over 2. And that makes sense because sine is the reciprocal of cosecant. If you take the reciprocal of 2, you get 1 over 2. This is an equivalent equation. So now, to solve for theta, we would just do sine inverse. of 1/2. And if you type in sine inverse of a half in your calculator, you will get 30 degrees. So we don't evaluate for the angle by using the inverse. We use the reciprocal. We have no cosecant inverse button. So we change it to sine, and we use sine inverse. Similar to these two secant questions. I'll do the first one, you'll do the second one. Secant is related to cosine. It's 1 over cos theta. So if we wanted to solve for theta, we could rewrite this as cosine, and that would flip the ratio, root 3 over 2. And now we can do cosine inverse. Theta would be cosine inverse of root 3 over 2, which is also 30 degrees. So what I'll actually get you to do is I'll get you to do C and D. There's nothing tricky about either of them. It follows pretty much the exact same methodology. It'll work out as decimals though. It's not going to be as nice as the 30-degree ones. Okay, so try C and D on your own, and that's it for lesson 5.1. Thanks for watching, and I'll see you next time.